Your career begins here at Satyabama Institute of Science and Technology, a deemed to be university, a nationally recognized and globally acclaimed destination to accomplish your academic aspirations. The Colonel Dr. JPR Research Park, along with the International Research Center, houses advanced research facilities that have 13 centers of excellence, 10 plus technology transfers, 100 plus patents, 10,000 plus reputed publications. The Satyabama Center for Advanced Studies is a state-of-the-art facility built with the aim to cater to the futuristic aspirations of our students with the aid of a metaverse studio, drone labs, maker's space, media center, advanced characterization facilities, ICT-enabled classrooms, and supercomputing laboratories. The engineering departments are equipped with sophisticated infrastructure, fulfilling the academic and hands-on requirements of our students. The architecture department is furnished with sophisticated design studios and spacious drawing halls, all of which support the learning process of our postmodern generation architects. The Satyabama General Hospital, along with the School of Dental, Nursing, Pharmacy and Physiotherapy, have advanced clinical facilities. The monumental Central Library houses a diverse collection of books, periodicals and journals. Additionally, it also has an open-air theatre with a seating capacity of 1,000. The Management, Arts, Science, Law and Hotel Management departments comprise of all the necessary and required facilities, creating the perfect ambience for our far-sighted students and catering to their skill set needs with the end goal of equipping them to live their dream. Our chain of laboratories with practical exposure equips our students to build a successful career. Our institution has a team of dynamic and outstanding teachers who are ever reachable to our enthusiastic students, promoting the spaces to learn and places to grow. Greenery around the campus greets and accommodates our students, who are the backbone of a developed nation, edging them on to achieve the summits of their success. Satyabama Institute of Science and Technology.
Tawfiq, can you listen? Tawfiq na Ganesh ba. Can you listen me?
Yes, sir. Yes, sir. Yes, sir. Yes,
The
sir.
Karthik sir is unable to connect.
Sir,
Audio is
sir.
not coming. Can you just check it?
Okay, sir.
Yes. He's waiting still. Else remove him and admit him again.
Sir, actually, he is already in, sir.
No, ma, he's facing a technical difficulties.
Okay.
Okay.
Uh, can you hear me?
Yes, sir.
Okay. Uh, Tawfiq, shall I go start and go ahead?
Sir, first I'll tell the introduction, sir.
Yeah, sure. Go ahead.
So good afternoon, everyone. Welcome to today's Ocean Research Knowledge Series 2026 session organized by Center for Ocean Research and NCMR, National Facility for Coastal and Marine Research. Today's lecture is on fish salines for lab-grown meat. We are delighted to have Dr. V. Karthik, Assistant Professor Research, Center for Ocean Research, Satyabama Institute of Science and Technology as our speaker. I request all participants to keep their microphones muted and post your questions in the chat box. You can continue, sir.
I hope my screen is visible to everyone.
Yes, sir.
Yes, sir.
Okay. Okay, fine. So Tawfiq, thank you for the introduction, and I just want to take the opportunity to welcome you all and to gathered here for and spending your time for this short lecture. I'm Karthik. I'm currently associated with Center for Ocean Research, and we are doing some fish cell line development for the purpose of lab-grown meat. And I just wanted to give a brief introduction about how we do that, all those things. Yeah, so I do not know how many of you have heard about this cellular agriculture stuff. But it is an area which directly relates to sustainable, you know, a way of preserving things in the ocean ecosystem. We are primarily focused on developing fish cell lines. The reason behind that, there's an increased demand in global seafood, and then the overfishing of marine species, and then many fish stocks are overexploited. Also, climate change plays a huge role in habitat loss, pollution, and acidification, oceanification. So, food security is the need of the hour, and so that's probably one of the reasons that many companies throughout the world are trying to develop, a lab-grown meat as an alternative source. So, the current challenges that what we face, both in as well as academic as well as industry, is that developing a fish cell line itself is a big task because the when it comes to mammalian cell lines, we have a stability in the cell lines, but when it comes to fish, the problem is you know if you go to many passages, probably the cells will lose its uh, ability to proliferate, and that becomes a problem. It's a concern, huge concern. There's a research gap that needs to be addressed here, and when it comes to do it in several ways. Either you can use a plant-based edible scaffold or a seaweed-based edible scaffold, and then you try to develop a meat-like structure, patty with pulling together different cell types, fat cells, muscle cells, so that you get the texture of when you take a bite of a meat, you feel you do not just eat only muscle cells. There are fat cells involved in it. There are cartilaginous type of cells will be there. So all together will give that a meat-like texture and the umami flavor. So mimicking that is extremely challenging, and there are a lot of R&D is currently going on throughout the world. Many companies they do the R&D in developing cells as well as lab grown meat. So that's just basic about the work. So these are all some companies who are planning to develop their own lab grown meat. For instance, this Upside Foods, Mission Barnes, Good Meat, Help Farms, Finless. These are all and most of them are US or Israel, Singapore. They are having a lot of companies like this. These are just some of the companies who are working on uh, uh, similar technology. I'm sorry. Yeah, when it comes to the Indian scenario, we have Biocraft Foods here, and then the Umami Bioworks is based out of Singapore, but they do have an Indian counterpart here in Bangalore, where we have tied up and developed fish cell lines from grouper, and we try to use a red snapper, and they are also working on developing eel, which is unagi, Japanese eel, and of course our government institute ICAR, Central Marine Fisheries Research Institute in Kochi is trying to develop cell-based meat in connection with a startup called Meat Meat. So there are plenty of activity going on in India as well. So it is not something new to us in the Indian ecosystem. There are companies and there are institutes. CFTRI Mysuru is working on it, and as well as Amity University and in Mumbai. There are plenty of other research labs. They are also focusing on this sort of work. Yeah, this is the global recognition. These are some of the companies who have got funding from angel investors. They've got very good infrastructure to support their work. Some of them are, ESG Investment, Temasek Holdings, and Nutrico, Thai Union. So they're all big players. They are trying to develop sushi grade meat, bluefin tuna based, and then even chicken, as well as other uh, mm, uh, you know platforms they are working on. So this is something which has been going on for some time now. Yeah, our research. So we are mainly interested in developing a seaweed or plant-based edible scaffold, uh, and then we wanted to develop uh, meat-like texture by incorporating cells. So that is the whole idea. But the challenge really lies with the addition of the cells to the scaffolds. It may be a plant-derived scaffold. It may be a seaweed-derived scaffold. When you try to achieve addition with the edible scaffold, you may not at first, maybe at the initial stages, you may not have a very good addition. So that becomes a problem when it comes to developing a edible scaffold or edible uh, lab grown meat. So we wanted to address that challenge. So we are trying to use mechanobiological aspects. For example, we try to use mechanical stimuli or an electrical stimuli so that you can have a better adhesion with the scaffold. So that is something that we are also working on in our Center for Ocean Research. Plus, we are also trying to develop clusteroids from fish cell lines. So there are not a lot of research been going on with regard to clusteroids. There are plenty of research that has been going on when it comes to organoids with mammalian cell systems or other mammalian organoids. There is very less report on fish cell-based clusteroids. So we want to take that challenge, and we are currently working here at Center for Ocean Research. We've got a very good infrastructure to support these studies, uh, both technically as well as when it comes to infrastructure in terms of instruments. We got a very good team. We are working on it here. Yeah. So, like I said, we wanted to mainly focus on plant-based scaffolds to support fish cells as well as clusteroids to produce meat-like tissues. So some of the facilities that what we have here with us in Center for Ocean Research, we have got a very good clean room facility which comes with ISO 7. And then we've got a biofermentor from Eppendorf. We have got a bio AFM, a confocal microscopy, a cryoplaner, and then a cell counter. All the basic infrastructure required for developing cell lines we have. And we welcome who are interested in pursuing research in this sector. We'll be happy to hear from young minds like you guys. These are all some of the training sessions that we performed, trainings, workshops, specifically addressing the challenges in developing fish cell lines, and workshop related to it. These are some of the pictures that we taken during our programs. Yeah, so this is more or less the work in a short form. So we try to take a fish explant culture, and then we try to develop muscle progenitor cells, and then either it's a plant-based protein or it's a seaweed-based scaffold. We try to seed them. We try to see if they have a very good adhesion, and then we try to characterize it, and then ultimately we want to have a very good edible meat. So that's the ultimate purpose. Yeah, so I want to focus on this particular type of research, which is the tubular alginate tubes. So alginate is not alginate is something that is not new to us. It is it's a very good bio compatible system where you can it's easy, it's cost effective, and we try to use cells inside alginate tubes, alginate shells actually. We try to grow them, which is challenging, of course, but then we try to achieve some sort of growth in the tubes so that it will look like a edible scaffold altogether for the purpose of edible meat. So when we try to load cells, the cells proliferated, and then we got a very good initial data on it. So we are also working on other scaffolds as well. So this is just a coaxial flow system which we developed in-house in our laboratory by a couple of my PhD scholars. So where they used coaxial flow system to develop a tube-like polymeric solution. You can use any polymer. You can use alginate. You can use any polymer for uh, to start with, and then you can get a uh, porous noodle-like structure, which you can use it for growing your cells. It may be mammalian or maybe other cells also. So we here in this case we try to use fish cell lines. So this is the whole architecture. I don't want to get deep into it. So when we try to use this system, this is how the system looks like, and then we got a tube-like structure like this. Here you can see very well the noodle-like structure. It's transparent, which allows you to take very good images in microscope, so it will tell you whether your cells are there or not. So that's the advantage of using this particular system. Yeah, so as you can see that in the control, I mean, it doesn't have any cells, so it looks, plain blank. But in the 0th day, we try to load cells here. You can see the cells, adherent cells here. And then in the 4th day, there you can see some sort of proliferation. And in the 16th day, there are a lot of cells grown on it. So this is a very good direct result that we wanted, so that you can use this system to scale up to much larger proportions. So ultimately, you have an edible alginate. You also have fish cells. So altogether, everything is edible now. So if you can do it and if you can do it in a large scale, you may be able to come up with you know very big patty. So that's the ultimate purpose. Yeah. So I want to talk a little bit about a Good Food Institute. It's a US based think tank. They also have their office in India. We recently got so they Good Food Institute is supporting uh, universities throughout the world. I think they support about 80 odd universities throughout the world. And I'm happy to share that Satyabama is one such institute where we got the smart protein project, which is supported by Good Food Institute. So this we got it in year 2026, April 2026 to be exact. So this allows us to directly involved in the alternate protein sector. uh, they focus on so many different ideas like plant-based, cultivated, fermentation, eggs and dairy and other products. But we wanted to focus our work mostly on fish based lab grown meat. So this is our logo. It will be launched in the mid of August, where our students, Satyabama students and other scholars, they will be actively participating in similar interest uh, what GFI and Satyabama share, which is developing an alternate protein hub at Satyabama Institute of Science and Technology. So it's a very good recognition that we have received. We'll be happy to start the work soon. So yeah, this I think yeah, it's about 90 plus student chapters across leading universities worldwide since 2020. They have given supported up to 90. So we are one among them. Uh, Allows you to provide mentorship to students directly, help the students to uh, work on a research and innovation in a alternate protein ecosystem, and also empower students to build courses research. They can even take up entrepreneurship, and they can also get in touch with the regulatory bodies across India. So you can get the alternate protein on your table. So this is something that we are proud of. Yeah. So on the whole, our Center for Ocean Research, our main focus is that we do a lot of research activities with trust areas spanning from marine ecology, marine microbiology, marine biofouling, so on and so forth. So one thing that we are very strong in is that we help in educating students and young minds through guest lectures, through collaborations, and then by networking with proper industries. We're also engaged with the NGOs. We're also engaged with foundations, and we do have some international exposure also in Japan and other countries. So it will be a very good opportunity for young minds to get in touch with us. So I just want to say this at this forum. Yeah. Thank you.
So thank you, sir, for the
So
informative lecture.
yeah,
We
so
will-
if there is any questions or any comments that I'd be happy to take a few questions, few easy questions actually.
Sir, actually, there is a question in the chat box, sir. Whether nutritional factor of lab-grown meat is similar to the ordinary meat, sir?
Yeah, so this is that's a very interesting question actually. So the lab grown meat will not have an exact nutritional value as that of meat. The reason being that when it comes to meat, I think I mentioned this in the lecture also. When it comes to meat, the meat is composed of several different components, not just the muscle part of it, that is the meat. It has fat cells, it has muscle, it has collagenous material, it has plenty of other things. So on the whole, it has plenty of components. But trying to mimic that is a challenge. I won't say it is not possible, but it is challenging but doable. In the lab, we are trying to develop. So to address this challenge, we would be co-culturing 3 or 4 different type of cells, and then make it somewhat equivalent to the regular meat what we consume. But it is a challenge, but it's possible. That's a good question. Any other questions? Okay, then if there are no questions, if anybody wants to get in touch with us, you can contact Tofik or any of our group members here. We'll be happy to talk any research if that is interesting to you. We'll be happy to collaborate with you all. Thank you very much.
Thank you, sir. So details regarding our center facilities, characterization services, internship workshops, and MSc Marine Biology related admissions has been shared in the chat box. So kindly have a look. Thank you.